So in this question, they've first asked us to prove the identity sine theta plus cosine theta times 1 minus sine theta cosine theta is equal to sine cube theta plus cosine cube theta. Now, one way to solve this question over here is if you look at the left-hand side they've given us, we can solve the left-hand side or simplify the left-hand side to be equal to the right-hand side. Now, if you notice, if we distribute sine theta and cosine theta across the brackets, what we realize once we open up the brackets, the maximum power of sine theta will be 2. So if we multiply sine theta times 1, we get sine theta, and we get minus sine squared theta cosine theta. Same with cosine theta. If we multiply by this guy, we get minus sine theta cosine squared theta plus cosine theta. So the maximum power of sine or cosine that we get is 2. Or on the right-hand side, we notice that the powers, that sine theta and cosine theta, are to the third power. They're both cubed, which means that there must be some additional sine theta and cosine theta that we have to add in here to get that higher power. Now, if we notice, we know 1 over here is simply the sum of sine squared theta and cosine squared theta. We know 1 is equal to sine squared theta plus cosine squared theta. So that's our first hint. We can say that this identity, sine theta, can be written as sine theta plus cosine theta times cosine squared theta plus sine squared theta minus sine theta cosine theta. So all we've done is we've replaced 1 with cosine squared theta plus sine squared theta. Now if we distribute sine theta, we get sine theta cosine squared theta plus sine cube theta minus sine squared theta cosine theta. So we've just distributed, we multiplied everything on in the right bracket with sine, and now we're going to distribute cosine. So we get plus cosine cube theta plus cosine cube theta plus sine squared theta cosine theta minus sine theta cosine squared theta. Now we have to simplify. Now if you notice here, we have a sine theta cosine squared theta over here, and we have a minus sine theta cosine squared theta over here. So these two should cancel out. Similarly, we have a minus sine squared theta cosine theta over here, and we have a plus sine squared theta cosine theta over here. So again, these two also cancel. So what we're left with is sine cube theta plus cosine cube theta. We're left with sine cube theta plus cosine cube theta. So we've proven that if we simplify the left-hand side, we arrive to the right-hand side. So now both sides of this equation are equal, and hence we've proven the identity. Now the second part says, hence solve the equation sine theta plus cosine theta times 1 minus sine theta cosine theta is equal to 3 cosine cube theta for theta between 0 and 360 degrees. Now, since it says hence solve the equation, what they're trying to say is, okay, if you notice here, this guy is the same as this guy over here. So what we can use is we can substitute sine cube theta plus cosine cube theta for the left hand side in the second part. So we can say for part 2, we can say that sine cube theta plus cosine cube theta is equal to 3 cosine cube theta. So if we simplify, we get sine cube theta is equal to 2 cosine cube theta. We just subtracted cosine cube theta on both sides. And now we know that if we divide both sides by cosine cube theta, we get sine cube theta divided by cosine cube theta is equal to 2. And the reason we did this is because we know that sine theta over cosine theta is simply tan theta, right? That's just opposite over adjacent. So we have sine cube theta divided by cosine cube theta is equal to 2, which means that tan cube theta is equal to 2. So we can say that tan theta is equal to the cube root of 2. And if we take the arctan of this, or the tan inverse of cube root of 2, we get theta is equal to 51.6 degrees. Now, is this the only possible value for theta between 0 and 360 degrees? Well, what we've already learned is that over here, if we look at theta, it's 51.6 degrees. And tan theta is positive cube root of 2. So the opposite, which is the y coordinate, is positive, and the adjacent, opposite over adjacent, is a positive value. We also know that tan theta, it must be positive in the third quadrant, where the opposite is a negative value and the adjacent is a negative value. So we have the same angle with the x-axis, which is 51.6 degrees. But if we measure the angle counterclockwise from the positive x-axis, we get 180. We get 180 plus 51.6 degrees. So the other possible value of theta over here, the other possible value for theta over here is 231.6 degrees, which is 180 plus 51.6. So our two possible values for theta are 51.6 degrees and 231.6 degrees.